Welcome to class of physics. In this class, we are going to study about the Poynting theorem. With this Poynting theorem gives the rate of flow of energy or rate of transfer of energy from source to distant point or from one point to another point. Okay. As electromagnetic waves propagate through the matter from their source to distant receiving point, there is a transfer of energy from source to receiver. So that transfer of energy is given by this Poynting theorem. Now let's derive the Poynting theorem using Maxwell's equations. Here we are considering two Maxwell's equations. So that is equation number 3 and equation 4. The third equation gives del cross E equal to minus dou B by dou T, and another equation is del cross H equal to Z bar plus dou D by dou T. Here E is electric field, V is magnetic field, H is intensity, J is that is current density. So now using these two, we are going to derive the Poynting theorem. Taking dot product on both sides of equation 1 with H. Okay. Now I have to take a dot product with H for equation 1. So then it becomes H dot, and here also dot. For that, this equation 1 becomes H dot del cross E equal to H dot dou B by minus of dou B by dou T. So write as it is, H dot del cross E equal to H bar dot, here B is mu naught H, B is what it is, mu naught H. Okay. Using this relation, we are going to modify this B by mu naught H. Mu is constant, for that writing outside, so it is dou H by dou T. Now I have to differentiate this one. Actually this is what, minus of mu H dot dou H by dou T. So this is the equation. Now I have to override this one. So when you simplify this one, it becomes minus of dou B by dou T 1 by 2 mu H square. Here the H is vector quantity. Now after simplifying, it becomes H square. Here H square is the H is scalar quantity. So that how to simplify this one. In the box I simplified. Okay, H dot minus dou B by dou T. So as it is here, minus dou by dou T. So this is dot product taking inside the differentiator. Then it is dou by dou T. H dot H. So H dot H, here two vectors under dot product, then unit vectors are same. For that we can write it as H square. Here the H dot H becomes scalar H square. Now dou by dou T H dot H. So also differentiate this one. When you differentiate this one, or partially differentiate using UV form, so then simplify this one, it becomes H dou by dou T H plus H dou H by dou T. Here one is U P. Okay, then this is in terms of U into dou by dou T of V plus V into dou by dou T of U. So like that, after differentiating under UV form, so we will get this term. So that is equal to minus of dou by dou T mu H square. So here these two are the same terms, H dot dou H by dou T plus H dot dou H by, so that it is 2 H dot dou H by dou T. Now take this 2 into left side, sorry, in right side. Okay, now take this into right side, then it becomes 1 by 2. So 1 by 2 mu H square. What is left in left hand side? It is H dot minus of mu dou H by dou T. So that is the term here. Okay. So that means this term can be replaced, this whole term can be replaced by minus of dou by dou T 1 by 2 mu H square. So that is here. Here H is scalar quantity. Don't write arrow mark on this H. Okay. So call this equation number 3. So what is equation number 3? H dot del cross E equal to minus of dou by dou T 1 by 2 mu H square. So call this equation number 3. So now the dot product for first equation is complete. Next again take dot product for the equation number 2 with E dot, with E. Okay. So then follow the same steps whatever I explained in this part. So equation number 2 is del cross H equal to J plus dou d by dou t. When you take the dot product with EVA, then it is EVA dot del cross H plus E dot J plus E dot dou d by dou t. Actually the right hand side term is J plus dou d by dou t. Now I have to take dot product, so that this dot product is multiply or operate with these two terms. So it is E dot J plus E dot dou d by dou t. Then so this one is as it is and this is also as it is, but I have to simplify this one. So after simplifying, this term becomes dou by dou t 1 by 2 epsilon E square. Okay, call this equation number 4. Now we get equation number 3 and equation number 4 by using equation 1 and 2 under dot product with H and E. Now subtract equation number 4 in equation number 3, or equation number 3 in equation number 4. So this is equation number 3, equation number 4. Subtract this equation number 3 in equation number 4. For that, left hand side is E dot del cross H minus H bar dot del cross E. Okay, so that is here is equal to equation number 4 is this one, right as it is, E bar dot J bar plus dou by dou t 1 by 2 epsilon E square minus, so this minus becomes plus. For that, this term is dou d by dou t 1 by 2 mu square. So these two terms are same, dou by dou t. For that I am taking it as common, so it is 1 by 2 epsilon E square plus 1 by 2 mu S square. So but according to the identity of this vectors, del dot E bar cross H bar can be written as H dot del cross E minus E dot del cross H. So this identity can be explained like this using the vector rule, vector or vector trivial product. Now we are going to replace this term H dot del cross E in this equation. For that, whatever the terms remaining in this except this H dot del cross E, take it to one side. For that, H bar dot del cross E, so that is equal to del dot E bar cross H bar. So take this into another side, then it becomes plus. For that, this plus E bar dot del cross H. So equation 5 becomes, so using this relation, which one? This one. Using this, rewrite equation number 5. Just replace this term by these terms. So then this equation becomes, so first term as it is, E bar dot del cross H minus of, so H dot del cross E, so that is equal to del dot E cross H. So here minus is the minus, then again minus of another term is E dot del cross H, so that is equal to the remaining right hand side terms are as it is. So E bar dot J plus dou d by dou t 1 by 2 epsilon into E square plus 1 by 2 mu H square. Now these two terms are same of opposite sign. For that, these two get cancelled. The remaining is minus of del dot E cross H is equal to, so right hand side term is as it is, E dot J plus dou by dou t 1 by 2 epsilon E square plus 1 by 2 mu S square. Now let us consider a volume V enclosed by a surface S. Now considering a volume, so that is enclosed by a surface S. Using this volume, we are going to integrate this above relations. So when you integrate this above relations, okay, so integrate, and this one also integrate over a volume V. This is volume integral, this volume integral, and volume integral. So when you integrate volume integral, this is becomes dV, and this is also dV, and this is dV. That equation is writing here, dou by dou t 1, okay, integral 1 by 2 epsilon E square plus 1 by 2 mu S square to dV. So this integrate with respect to volume. So the second term is also as it is, and another term is integral del dot E cross H dV. Now using using Gauss divergence theorem, this volume integral is converted into surface integral. When you convert this surface integral, what happens? This is eliminate and this becomes circular integral. So this becomes ds, that is, so this term becomes circular integral over surface S is E bar cross H bar into ds. Okay, so that is here. Using Gauss divergence theorem, we can write volume integral to surface integral like this. Then replace this term by this surface integral, then this becomes minus of dou by dou t 1 by 2 epsilon e square plus 1 by 2 mu square dv minus minus integral of E dot j dv equal to surface integral E cross H ds. So this is the Poynting's theorem, the last equations. Sure, what these terms indicates? The first term is on left hand side, that is minus sign. The second term is also minus sign. So what it indicates? The first term on LHS side represents the rate of decrease of energy stored in a volume V due to the electric and magnetic fields. Here this term indicates the energy. Here E square is the 1 by 2 epsilon E square. This term indicates the electrostatic energy, and 1 by 2 mu A square indicates the magnetostatic energy. So this total term indicates the energy stored in volume E. This minus sign indicates there is a decrease of energy, so that is stored in volume E due to this electric and magnetic field. And then second term on left hand side represents the rate at which electromagnetic energy is lost through Joule heating effect. Okay. This second term indicates this is also the loss of energy or decrease of energy that is due to Joule effect. Okay. That energy is electromagnetic energy, and so here this is decrease of energy and this is energy lost. Now that is equal to the right hand side equations, that is E cross H dot ds. Hence the right hand side represents the rate of flow of energy over a surface S enclosing the volume V. Now this indicates the rate of flow of energy over a surface S enclosing the volume V. So therefore E cross H gives the rate of flow of energy through unit area enclosing the unit volume. So this denotes by vector P, that P equal to Poynting vector. The Poynting vector is given by P bar equal to E cross H. So keep this highlight. So this we call as Poynting vector. The Poynting vector is E cross H, and according to Poynting theorem, the rate of flow of energy over a surface S enclosing the volume V, that is equal to the minus of dou by dou t 1 by 2 epsilon E square plus 1 by 2 mu square minus of E dot j. Okay, this is the Poynting theorem statement and the derivations. The last equation represents the Poynting vector P. For this, the syllabus is complete. Next class we'll continue with another topic. Thank you.